All right. We are going to start with chapter 3 today. If you haven't noticed, geometry's got a lot of terms. It's got a lot of things. You got to know what they are and then be able to apply them. This chapter has even more. We first start out in this chapter on this front page notes, and we go through a whole bunch of different definitions of angle types. The key is, as you probably have kind of figured out already, you might have to actually do some studying in geometry. Because you need to know what these angle types are, you need to know what they look like, and you need to know facts about them. And that means you might have to do some memorization. Looking at the picture and figuring out which one they are is probably the easier of the two items, because we're going to show you pictures of them over and over and over again. But then remembering what relationship they have to each other, that one's going to take a little extra studying. We'll do enough problems in here and on homework to probably help with that, but this might be the time where you actually have to sit down with your notes, read them over again a couple times, quiz yourself on it. Do those memorization techniques that you learned for all those other English classes and social studies classes or science classes where you had to know a name and a definition of it. You had to be able to match them together. This is that same kind of idea. So you're going to want to do a little extra practice with this stuff. Don't just count on what we do in class being enough, because if you can't recognize the angle types that we go through today, the next step is super hard. But if you spend a little time working with the material, that next step's not as hard. And it makes the problems that we do make more sense because you know why you're doing what we're doing. We're not just throwing numbers in an equation. A lot of times people are like, I don't know if I'm supposed to set them equal or add them. Well, you've got to know what type of angle they are to know which one you have to do. So there's some studying involved in it. But first thing we got to do is actually learn about them so that you can study them. So the very first thing we talk about is a transversal, and that's a line that intersects two lines at two distinct points. So when I'm looking up there at that picture, is L or T or M the transversal? Which one's the line that intersects two lines at distinct points? Yeah, T. Absolutely. T is your transversal because it's cutting through here and it is hitting L and M in a distinct point for each one. When we talk interior angles, we're talking inside the two lines. So not worried about the transversal, but the angles that are formed inside or in between the two lines. So when I look at angle 3 and angle 6 being interior angles, what other angles are interior angles? Angle 4 and angle 5. So we're talking inside, in between L and M, because T is my transversal. Which then leaves what angles for exterior angles? 1, 2, 7, and 8. Notice I'm putting an angle symbol on all of them. And you always want to have that angle symbol in front. Okay, then we get more specific. So interiors in between the two lines, exteriors outside of the two lines. But then we have alternate interior. Alternate interior angles are interior, so they're inside. They have different vertices. And they're on opposite sides of the transversal. So they're interior. They have different vertices, which means one's with line L and one's with line M. And they're on opposite sides of that transversal. Remember, T is our transversal. All right, so I'm going to trace this angle 3 and angle 6. So here's angle 3. Vertex is up here on line L. Here's angle 6. The vertex is down there on line M. So that's my different vertices. We already said 3 and 6 were interior angles. And now we're being very specific about those interiors. One's on the left side of that line T and one's on the right side of line T. So give me another pair of alternate interior angles. 3 and 6 is one pair. What's another? Angle 4 and angle 5. Okay. One thing that sometimes helps people is, as I look at this red tracing that I did, what letter is that? A Z. A lot of people can remember alternate interior by remembering the Z. For 4 and 5, then we obviously flip the Z over, but it's the Z angles are the alternate interior ones. All right. Then we want to go same side interior. Same side interior are still interior. They still have different vertices. But this time, they're on the same side of that transversal. So they're interior with different vertices, same side of the transversal. Good? Okay. All right, so the example of these same side interior angles are 3 and 5. Give me another pair of same side interiors. Somebody new, talk to me. 4 and 6. Perfect. Okay, so alternate interior, they got to go either side of the transversal. So you got to pick out which one's your transversal right away so you know where that transversal is. And then same side, they stay on the same side of it. Okay, when I abbreviate these, I make alternate interior just alt int because I don't like to write that much. Same side interior, I do SS int so that I don't have to write out the full words. This saves me a little bit of time. All right, I'm going to go over to the left there where it says alternate exterior because they're very similar, but instead of having interior for that first word, we're going to have exterior. But they have the different vertices. And they are on alternate sides of the transversal. Or opposite sides might be a better word there instead of alternate because I just used the word in the definition. So if 3 and 6 were alternate interior, give me a pair of alternate exterior. 7 and 2 is one pair. So we're up here on the top, on the right up outside. 7 bottom outside. 8 and 1 I heard? Absolutely. So opposite sides of that transversal. One's on the left, one's on the right. So the only thing that changes for same side is they're not on opposite sides, they're on the same side. So exterior, different vertices, same side of the transversal. Yeah. 2 and 8 is one pair, absolutely. Somebody else give me another pair. 7 and 1. Okay, so I know it's a lot of writing. You're never going to have to write down the qualities of the angles. you're just going to have to be able to pick them out. So I'm trying to give you key points for how do I look at a picture and decide which one it is. Just like the other ones that I abbreviate, this one's Alt-X, this one's SSX. Yeah. That's the Z over here with the alternate exterior. When you look at alternate interior angles, they look like the letter Z. So it's just kind of a visual, how do I look at it in a picture, what do I see? Good question. Are we okay with all those? Okay, we have one more type, and that is corresponding. Corresponding, instead of both being interior, both being exterior, has one interior and one exterior. So one of each. Obviously, or not obviously, we're going to have different vertices so that we use all three lines. And then you're going to be on the same side of the transversal. So how is this one different than same side interior? Yeah. Because you have an interior and an exterior. When I think corresponding, I think I'm picking up one of the lines and I'm placing it on top of the other one, and I'm picking the ones that are in the same. So for instance, angle 1, if I picked up line L and just shoved it down on top of line M, angle 5 would be in that same spot. In the 4 angles, it'd be the top left one. So it's just what's in the same spot. If I pick the line up and put it down on top of the other one, where would they be? So give me another pair of corresponding angles. 2 and 6. Because if I picked up upper right off of those 4 angles of L, upper right off the 4 angles on M. Another one, yeah. 3 and 7. And then somebody new give me the last 8 and 4. Nice. Okay, so you're looking at visually, it's same location in the group of 4. If it helps, pick up the line and move it down. But you got to have one on each line. So the L and the M are the 2 lines we're talking about because it's 2 different vertices, so I can't be within just the L and T. I have to have the L and T matching up on the M and T. Questions? All right, there's a lot of definitions there. Goal is to be able to just visually look at the picture and pick them out. Which is why one of my first questions here is, are angle 4 and angle 3 alternate interior? Here's angle 4. Here's angle 3. Are those alternate interior? Okay, talk to somebody next to you, see what they say. You talk about it and decide what's making one person think it is and one person think it's not. Talk to a different person. Look to somebody else, see what they say. See if it changes your mind or not. All right, what are we thinking? Okay, tell me what it takes to be an alternate interior angle. What qualities does it have to have? Inside the two lines. That's covered. Okay, so it's interior. What else? Yeah. Different vertices. Do 4 and 3 have different vertices, a different vertex for both angles? No. They share it, right? So this is a no. They are not alternate interior angles because they share that vertex. To be alternate interior, you have to go to two different vertices. Now, before you turn that page, when that shows up on your quiz, I'm going to ask you for a different word for that. What are 3 and 4 to each other? Turn and talk to somebody next to you. See if you can come up with a relationship that 3 and 4 do have. And you want to stay on that front page so we can write it down. Think of a relationship 3 and 4 do have. You could have used it last chapter. Over here had it. Yeah. They make a straight line. So they're not alternate interior because there's not different vertices. When two angles make up a straight angle, how much do they add up to? 180, which makes them what word? Starts with an S. There we go. And I go for that word specifically because when you take the quiz on this chapter, that's the word you're going to use. There's going to be some underlined terms throughout the page that allow you to pick from these terms to identify the word. Supplementary is the word that's on that page for you to go with. Okay, so they are a linear pair. They do make a straight angle. We go that step further and say that straight angles add up to 180. All right, when you turn the page, if you don't have a protractor, I need you to come up and grab one because I would like you to measure angles 1, 2, 3, 4, 5, 6, 7, and 8. So there are protractors up here on the table. Go ahead and measure those 8 angles. Remember, T doesn't go very far up for you to see where the angle hits. So feel free to extend your lines. Once you got angles in there, you can kind of double check with somebody around you. They don't have to be exactly on. Some of them will be slightly different. And that's okay because remember, everybody's measuring is just a little bit off from each other. But just double check if you kind of have the same general idea. All right, give me values. What do we got for angle 1 out there? Anybody? 115-ish? Close to that? Okay. If you got 115, what'd you get for angle 2? If you got something like 114, then you should add 66, right? Because what do those two angles have to add up to? 180. What about angle 4? 115, how about 3? Okay. 5, 6, 7, 8. So notice, again, if you had different numbers, the pattern should have stayed the same. Doesn't matter if they're exactly that number. Remember, I always give you plus or minus 2 when you're measuring with the protractor. But the pattern should be the same, which is why we can now first name pairs of, oops, I missed a page, didn't I? I should have answered the questions on the bottom. Name a pair of corresponding angles in this picture. So give me a pair of angles, not the measurements right now, but just the angles themselves. What angle numbers are corresponding? Remember, corresponding is like I pick up the one line and I move it down on top of the other. What's in the same spot? Angle 1 and angle 5. Somebody new, give me another pair. Angle 2 and angle 6. Somebody else who hasn't talked yet, give me another pair. Perfect. Somebody else give me another pair. It's the last pair available. Angle 4 and angle 8. When you do this, again, on the quiz, on the test in this chapter, you have to have an angle symbol in front of each angle number. And you are going to have to put in all 4 angle pairs. All right, what do we notice about those angle measures now? Angle 1 and angle 5's measures, 2 and 6's, 3 and 7's, 4 and 8's. What do we know about the measures of those corresponding angles? Compare the numbers. Angle 1 and angle 5. What can you tell me about those measures? Thank you, but no. I'm going to wait until someone else will speak up. I appreciate, though, that you keep participating. It's awesome. I need someone else to participate as well. Look at the numbers on angle 1 and angle 5 and tell me what those measures are. Yes, they are congruent. What about 2 and 6? Ladies and gentlemen, other people have to participate, please. This is a low stress one here. We already got a term for 1 and 5. Give me another for 2 and 6. Okay, turn and look at the person next to you and tell them the word that you can tell about angle 2 and angle 6. They are corresponding. We're looking for a comparison of the numbers for the degrees. All right, I heard the word out there a couple times. 2 and 6 both are how many degrees? 65, which makes them, they are acute, and to each other they are congruent. Does the same work for 3 and 7 and for 4 and 8? Okay, so we know that they're congruent. But did they look congruent on that page? No, 1 and 5 didn't look congruent. 7 and 3? 7's acute, 3 is obtuse. What's special on this page that wasn't there on the other page? L and M are parallel. So, we have to know a specific fact to be able to make the conclusion we just came up with. Our corresponding angles postulate says, if the transversal intersects two parallel lines, so we have to know they're parallel, then corresponding angles are congruent. So as long as the lines are parallel, we can make this conclusion. We cannot make the conclusion if the lines are not parallel. Questions? Okay, so now not only do you have to know what they are, what they look like, you have to know if the lines are parallel so you can tell me that they're congruent. How about alternate interior angle pairs? Right now, write down the two pairs of alternate interior angles. Remember, alternate interior make the Z. So write down the angle values. Not the number, not the numeric value, but the angle numbers where they're located for alternate interior. Then turn to that person next to you, see if they came up with the same angle pairs. If they haven't done it yet, see if you can help them figure out where those angle pairs are. All right, hopefully talking to somebody next to you gives you a little bit more confidence because I need somebody new to answer me. Give me a pair of alternate interior angle pairs. Josh, 6 and 3, that's one pair. Somebody else give me another pair. 4 and 5. What do we notice about the measures of those angles? 6 and 3 compared to each other. 4 and 5 compared to each other. They're diagonal. What about their measures? They're the same or congruent. Nice. So if a transversal intersects two parallel lines, then alternate interior angles are congruent. Again, I abbreviate a lot in here, so if you can't understand what I write, please let me know. Alt int angles congruent. It's just me breaking that down to as small chunks as I could write. Alternate interior angles are congruent as long as my two lines are parallel. All right, with that partner, find the same side interior angle pairs. Write down your same side interiors. Double checking them with the person next to you. All right, somebody new, talk to me. Same side interior, give me a pair. 3 and 5, another new person, give me another pair of the same side interiors. Just did 3 and 5. Somebody new, talk to me. What's the other pair? 4 and 6. What do you notice about those measures for angle 3 and angle 5 together? They do line up with each other. Yeah. They add up to 180. Because when you take 65 and 115, that ends up to 180. Does that mean they make a line together? Do they share a vertex? So they can't make a line together, right? If we took the angles separately, we could form them into a line, but in the picture as it is right now, it's just because they're same side interior. So if a transversal intersects two parallel lines, then same side interior angles equal 180, or R supplementary, however you want to write that. I go for equals 180 because it takes me less time. So if a transversal intersects two parallel lines and same side interior equal 180. Yeah. So there's a lot of different places in the picture where we add up to 180. So because these two have that same vertex and these two add up to 180, then knowing our corresponding are the same, we know that those two have to add up to 180. So yes, the line does 100% keep going. We do have linear pairs that are next to each other and make 180, but then we have to remember that we have those congruent angles as well. So we're kind of simplifying it down instead of having to take that step and go from 3 to get angle 1 and then angle 1 to get angle 5. We're simplifying that down to, okay, we can look at these and these two also add up to 180. Good? All right. Write down your alternate exterior angle pairs, please. With somebody near you, see if you got the same. All right, give them to me. Angle 2 and angle 7, somebody else different. Give me another pair. There you go. Okay, what do we notice about those angles? 2 and 7, or 8 and 1? What do we notice about their measures? Yep, they are congruent. So if transversal intersects two parallel lines, then alternate exterior angles are congruent. All right, then last but definitely not least, the same side exterior angles. Go ahead and write down those pairs. Same side exterior. I love how I'm seeing people look back. That's exactly what you should do when you're looking at this and going, I don't know what a same side interior is or same side exterior. Then you got to look back at your notes and figure out if there's another example of which ones are same side exterior on that previous page. All right, give me a pair. 2 and 8. Somebody else, give me another pair. 7, 1. So we got 2 and 8, 7 and 1. What do we notice about those measures? They're supplementary, absolutely. So we have this last one that if a transversal intersects two parallel lines, then same side exterior angles equal 180. Supplementary equal 180, whichever way you want to write it. But notice in all of our angle pairs, there's only two relationships. They're either what or what? Yep. Congruent or supplementary. So when it all boils down to it, you've got to know which ones are congruent, which ones are supplementary. Which ones are supplementary? the same side ones. In my head, same side supplementary, 3 S's. Alliteration helps me remember. All the other pairs are congruent, but same side are supplementary, 3 S's together. So I know when I'm going to set up a problem that I'm looking for, is it a same side that I know I'm supplementary or equal 180? Any other pair, I'm doing congruence. So if that helps kind of separate them in your head, same side supplementary, so the 3 S's. What it's going to take now is knowing those rules, because I'm just going to give you one angle and expect you to be able to give me the rest from it. I know this angle up here is 110. Does it look like it's 110? No. But what do you have to trust? The picture. The numbers tell you it's 110. So trust the numbers on the picture. I 100% understand it's not a 110-degree angle, because what kind of angle is 110? 2, so that's an acute angle that it's written in. Don't pay attention to what the picture's view is. Pay attention to the numbers in the picture. The other numbers that are there are not angles. Those are the angle, the marker in the angle to tell you where angle 1 is. So how much would angle 1 be? 110. Why? This is not one of the angle types that we had on these pages. It's one from last chapter. It's vertical. Nice. Remember when 2 lines cross, vertical angles. And we always know that vertical angles are congruent. So the directions say to give the measure of the angle and give a reason. So I'm giving 110 and then saying vertical angles are congruent. What do these arrows over here mean? The lines are parallel, which means all the rules we just discovered are fair game for finding other angles. 110 for angle 1, we didn't need any of those rules because I was only dealing with 2 lines. Transversal cutting 2 lines to make all those other angle pairs, we didn't have 3 lines involved. We only had 2. Okay. Do I need any of those rules for angle 2? The ones from today? No, because how much is angle 2 going to be? 70. Why? Absolutely. Either direction you want to do this, you know those two have to add up to 180. When it says give a reason, sometimes just writing down the math is the reason. You know they have to add up to 180, so you subtract. All right, now I need angle 3. How can I get angle 3? Yeah. Alternate interior with angle 2. It's the backwards Z. You know alternate interior angles are congruent. So it's not same side. Same side add up to 180. But that's not the only way I could have gotten angle 2. What other relationship is there for angle 2? What do you mean? Yep. But I need a newer relationship, a different one from that one, because that's the one we just used. We used the alternate interior. Yeah. Okay, we could have looked at same side interior. What do we know same sides are? Supplementary. So 1 being 110 gives me 3 at 70. So one of the things I do is on your homework, I make you write down that reason so I can kind of see your thinking. When I get to a quiz, I'm just going to have you give me the numbers because there's so many different ways you could get at them. All right, how about angle 4? Why is it 110? Okay, so we know these 2 angles have to add up to 180. Absolutely. Somebody else give me a different reason angle 4 is 110. Using one of the angle types from today. Yeah. corresponding to the 110 that's already there. So right here, I know those two are in the same spot. The lines are parallel, they're congruent. Somebody else, give me a different reason it's 110. We've used corresponding, we've used supplementary. I need another reason. Think of a different angle pair that angle 4 can get paired up with. Alternate interior. I know angle 1 and angle 4 have to be congruent because they're alternate interior angles. Give me one more relationship that angle 4 has out there. We do corresponding alternate interior. Makes a line with angle 3. Yeah. Same side interior with 2. Lots of different options for how to remember these or which one to use. All right, how about angle 5? Right here. What do we got for angle 5? Why? One of the many reasons why. Congruent, why? Congruent to what? So, give me the angle number that you're talking about the 110 on. 4? Then you'd be telling me because they're vertical angles. There you go. We could have gone with alternate exterior, the 110 that's out here to begin with that 110. We could have gone with corresponding. Angle 1 and angle 5 are corresponding. We could have gone with forms a line, because angle 3 and 5 form a line. Lots of different reasons. How about angle 6? Which is angle 6 going to be? 70. Give me a reason why. Basically pick any of them at this point. Give me a number or a type of angle. Corresponding. What's it corresponding to? Which angle? Yep. 180 minus 110 gets you 70. You know these two add up to 180. You know these two are corresponding, they're congruent. You've got vertical angles there. So you have the angle 1, the 110 we started with in 6 are same side exterior. They add up to 180. So lots of different reasons why. Is that okay? All right, so you're going to have to use those facts that we know about parallel lines to help you find things like here where I want to find angle X and angle Y. Right now with partners, see what you can figure out. Up and move to talk to somebody else. I'm going to make you do the next ones with partners first as well, because that's getting more people involved. All right. Give me some ways to get at these angles, because there are a bunch of different ways out there. Somebody talk me through one of them. Where'd the 50 come from? Okay, so you have this angle and this 70. Okay. Okay, because you know what type of angles, because here's my parallel line, here's my parallel line, here's my transversal. What type of angles are this angle and this angle together? The angle pair that we just talked about. Go ahead. They are same side interior. What do we know same side interior have to add up to? 180, because they're supplementary, right? So we know that those three, the 50, the 70, and the y, have to equal 180. And there's a bunch of different ways you could have gotten the 50 and the 70 adding up to 180 with the y. This is not the only way. So you got y to be how much? Okay. Now what? How do I get x? Subtract the 60 from 180. What else? What else besides the 60 has to get out of that 180? The 50, because how much do all three of these angles add up to? How much is x? Yep. Now, that being said, that is not the only way to do that problem. Because what kind of angles are the x and the 70 corresponding? So you might not have had to do any extra math there. You could have just looked at x and 70 and said they're corresponding, so they have to be the same. We could have looked at the 50 with my parallel lines in this transversal and seen that this 50 has to be the same where? What's the other corner of the z? Alternate interior have to be the same as well. So there are a ton of different ways to get at those two values, which makes this one a little bit more challenging for people because they look at it and they're like, I don't know what relationship to try. Stop overthinking, draw your angle in, and see what you can put in there. It doesn't have to be all of the relationships at once. Trace the angle you're looking for and see if you have a relationship with another parallel line. That being said, now let's try this next one. Go ahead and talk. Y and the angles. All right, talk to me on how to go about this one. Most of you have a pretty good start on it. What are we going to do? What do we know? Right, bottom left is a right angle because it's got a square in it. What else? What can we've got, what do these arrows mean? Parallel lines. So we can use the rules we got today because we have parallel lines. Remember, it's two lines cut by a transversal. So I have 4 lines on here right now. We got to ignore one of them. Okay, what one do we want to ignore? Don't pick one of the parallel ones. Okay, so if I'm ignoring the left one, I'm dealing with the y's and the y minus 50. What do you know about these two angles? What do they have to add up to? 180. So we got y and y minus 50 equaling 180. Yeah. Because you added the 50. So then what's y? Okay, so it said to find y and the angle, so I know this angle is 115. How much is this angle? Which should also be a check in your head. Does 115 plus 65 give me 180? Then I added to right. I did my algebra right. Okay, we ignored the one on the left to do that. How are we going to do the x then? Yeah. Perfect. Somebody else, retell me what she just told me about those two angles. Yeah. Perfect. Why did the top one have to be 90 as well? Yeah. Two lines are parallel. We again have same side interior. So what was phrased there twice was the bottom's 90, so the top is 90. Why? Because I'd subtract 90 out of my 180, and then we divide by 2 to get x is 45, and we know that that angle is also 90. All right, this next one, I'm going to put marks all over the picture up here for you, so you can kind of see what we do with problems that are as messy as this. Pick me a letter to find first. I heard W. So I trace W. Right now, I know that I want to use the lines that are parallel with W as part of the angle. So I can see the top part of W hits the line with 2 arrows on it, right? Where's the other 2-arrowed parallel line? Bottom. Here's my transversal going between those 2 parallel lines. What angle relationship do I have for W? 25, because it's the, what kind of angle with W? Alternate interior makes that Z. Okay, so we've got W taken care of. Pick another letter. Y. There's 2 Y's. If I trace the Y's, does tracing my Y's like this help me? No, because the alternate interiors are both missing, right? So maybe let's try a different letter first, because there's 2 Y's there that are missing. Say again. V. Tracing V. Going to its transversal. I'm going to follow its transversal until I hit the other parallel line. What do we got for V? Yeah. I think finding the opposites first makes it easier. Yes. You need at least one of, well, technically you did not need them because we could have gotten Y by using the angles up on top. So you need at least one, the W or the V or the X first. But then you could have found Y. What do we know W or V is now? 42, because again, you trace your angles. So we've got our alternate interiors. All right, so now I've got 42 here. Now what? We could get y at this point. We could have gotten y at the last point if I'd traced a different angle than the alternate interior ones. We could also get x. Which one do you want to get, x or y? X, okay. So if I'm getting x, tracing x, follow that transversal. There's my other parallel line. What do we know x is? Okay. Now I got to find y. Did the alternate interiors help me now either? No, because it's still y versus y. So what else can we do to get y? 180 minus just w? No, I think we're missing a little bit, right? You're right on the 180. Absolutely. Y is part of this bigger angle, isn't it? Well, here's my parallel line. Here's a transversal. There's another parallel line. What do we know all four, the 42, the 25, the y, and the 76 have to add up to? 180, because they are what type of angles? And? You missed one more angle. And 42. We need to get rid of all the 42, the 25, and the 76. Because they are what type of angles, these two that are in between my two parallel lines? And they're on the same side of that transversal, so they're what type of angles? Same side. Interior, they're inside. Why? $37. All right. What we're going to do next is you're going to take that parallel city packet that you had. And we've got a set of directions, and then you've got a picture. What you are going to do is put the building names on the appropriate corners of the Parallel City 2 sheet. So when you open that up, you've got a picture page and you got a direction page. If you want to unstaple, go ahead and unstaple. I just wanted to make sure I had those two together for you. There are a lot of different answers to this problem. Your goal, and I would use pencil on this for sure, is to put the cities in the corners. So like it says, the bank and Walmart are alternate interior angles. These three roads are all parallel to each other, right? Here's my transversal. There are a lot of alternate interior angle spots. Alternate interior angles here. So this one and this one are alternate interior. Reverse that. This one and this one are. I could ignore this middle line. This one and this one are alternate interior. I could deal with just the bottom two. This one and this one are alternate interior. Your job is to put the bank and Walmart in a pair of alternate interior angles. And then go on and put the gas station and post office as vertical angles. What do vertical angles look like again? Say again, I'm sorry. You don't want to repeat it? That probably shouldn't have got said in the first place, right? Okay. What do vertical angles look like? What crosses to give you vertical angles? Yeah. Diagonal, same vertex. Two lines cross to make it. So vertical angles are like here and here. So we've got vertical angles here. We got them here. We have all over the place. You got vertical angles. So you're going down this list of directions and you're putting the different buildings in spots on your picture, but all the statements have to stay true. So you might put one on and then you might have to move it because something else has to happen at the same time. So you might want to read all 7 construction informations first before you move on. And then start putting your cities, or your, not cities, sorry, your places on the map. All right, so you're going to go ahead and do that for me. When you're done with that, I'll check it and I'll give you your worksheet. Feel free to move around.